Hey there, welcome to Solve My Math Homework. We're the YouTube channel that solves the problems that our subscribers submit. And today we're going to determine intervals in which a function is concave up. So we're going to deal with concavity. And I'm going to tell you right now, concavity is not as difficult as it's going to seem in this problem because this function is literally the suck. I have never seen a function this ugly being given just to test concavity. But that's the problem that came in, so that's what we're going to do. So let's talk about concavity, okay? So you remember when we found where a function was increasing and decreasing and we used the first derivative test? So the first derivative tells you the behavior in relation to how it's increasing or decreasing. Well, the second derivative tells whether it's concave up or concave down. So if you were looking at a function, say like this, okay, this right here would be the concave up part, and this right here would be the concave down part. So from, you'd have this little inflection point here, and this is where it would change from going concave up to concave down. All right, so that's what we're talking about when we say concavity. So let's go ahead and look at the rules, and remember that this problem it's not typical of these types of problems. The hardest part about these is the second derivative, and that's for sure the case here. Okay, so concavity, we're going to use the second derivative test. It is exactly like the first derivative test. We are going to find the second derivative. We're going to figure out where the second derivative, right, is equal to 0 or where it's undefined. Okay, just like we did with the first derivative. And those are going to be called our inflection points instead of critical points. But they're the same, there are important numbers for our second derivative test. And again, the behavior or the relationship we care about is the fact that the second derivative, if the second derivative is positive, the original function is concave up, okay? And just like before, if the second derivative is negative, the original function is concave down. All right, let's get all this gobbledygook off the screen. This would be a great screen to take a screenshot of or get it written down, or just make sure you know this, okay? So when you think increasing, decreasing, first derivative test. Concavity, second derivative test. Okay, so let's just get into this one because it's kind of a ridiculous item, but we're going to do it anyway because we have to. All right, so the function is 10 times x times e to the x. So not too bad to take the first derivative. So f of x equals 10x times, some people put a little dot there to kind of remind you that, hey, if I see two things being multiplied, I've got to use my product rule, right? So f prime g plus f g prime. And that's what we for sure have to use here to get the first derivative. So f prime is going to be, well, let's see. So we already talked about f prime g. This might be a good case where just put your f and your g over here and your f prime and your g prime over here and kind of make a little table for yourself. So if f is 10x, then f prime is 10. G is e to the x. Well, guess what? That's its own derivative, so that's easy. And now you can kind of just use this and pick things out of it based on f prime g plus f g prime. Okay, you don't have to do this little table, but sometimes it's helpful. You don't get lost in your work. Okay, so f prime g, f prime is 10. So we got a 10. And g is e to the x, okay, plus f g prime. So what's f? F is 10x. And g prime, guess what? Same as g. If you know g, you know g prime. So e to the x. All right, so that is our derivative. Had to use a product rule, right? Okay, so very good. The bad news is that's only our first derivative. We now have to find the derivative of that. So I'm going to hedge my bets and go to another page. And I'm going to write f prime, and hopefully I can remember what I just wrote down literally a minute ago. 10 times e to the x plus, oh, look at that, I remembered it. 10x e to the x. All right. So that is our first derivative. Now we have to take our second derivative. Second derivative, this 10 here, don't let this confuse you. This is a constant multiplier. E to the x is its own derivative. So when we take the second derivative, that's simply going to be 10 e to the x. Okay? Now, it should look familiar. It's literally the function we started with, 10x times e to the x. So again, we do the product rule. F prime g. So f prime is 10, g is e to the x, plus f, which is 10x, times g. prime, which is e to the x. Or you could have just stolen it from our last derivative that we did. Okay, so that's f double prime. So that's the second derivative. We got to clean it up because it's a hot mess. Okay, so we basically have 10 times e to the x plus 10 times e to the x. Those are like terms. I can totally add them. Okay, so f double prime is 20 e to the x. Okay, now what else do we have? Anything else we can clean up? Not really, but we do have something else. So 10x e to the x. So plus 10x e to the x. All right, that is our second derivative. All right, that's harder than the entire problem, I swear to you. All right, so now what do we care about? We care about when the second derivative is equal to 0 or when it's undefined. So let's go ahead and rewrite it because I need a new page. Sorry about all the rewriting. Here's my second derivative again. It's 20 times e to the x plus, sorry about that, 10x e to the x. Okay, now we care about where it's undefined and where it equals 0. Okay, well, let's talk about undefined. So the domain of e to the x is negative infinity to positive infinity. So e to the x is defined everywhere. 10x is defined everywhere. If you multiply 10x to something that's domain is everywhere and you add it to something else that's domain is everywhere, you don't have any restrictions in your domain. So our domain is everywhere in this case. And thank goodness, because we really don't need one more thing to do in this problem. But we do have to figure out where this ugly thing equals 0. So factoring is going to be our friend. So we're going to say, actually, I don't even have time to rewrite this problem. Not time, but room. So we're going to factor this. So let's look just at our numbers, okay? At our numbers, we can take out a 10, and we can take out an e to the x from both. So we're going to take out 10 e to the x, and what's left? 20 divided by 10 is 2. E to the x divided by e to the x is 1, so I don't have to put that. Okay, 10 e to the x, 10 e to the x. Okay, that's going to cancel out, but we still have an x in here, don't forget that. Equals 0. Okay, so there we have 10 e to the x times the quantity 2 plus x equals 0. So if we remember 8th grade or Algebra 1, even Algebra 2, we are going to factor this guy. So we're going to say 10 e to the x, set that equal to 0. And I'm going to go ahead and say x plus 2 equals 0. All right, so 10 e to the x, well, let's see, to get 0, let's see, we divide by 10, raise something to a power and get 0. Can that happen? It cannot. So I don't have a solution over there. But here I have a solution. Minus 2, x equals negative 2. So we only have one inflection point. Our inflection point is negative 2. All right, moving on. So what do we do with our inflection point? We make this makeshift little number line, right? And we care about the sign of the second derivative before negative 2 and after negative 2. And I'm going to use two different colors so you can see what I'm kind of doing. Okay, so what I'm going to put in to these points, I don't really know. I'm going to use your calculator. Your calculator is going to be your best friend. Okay, f double prime of 0, well, that's going to be equal. Oh, you know what? Let's put this up here so you guys can see it. So we still need our second derivative. And that second derivative was 20 times e to the x. What is happening with my board today? Plus 10x e to the x. Okay, so when we plug in 0, we get 20 times e to the 0. E to the 0 is 1. 20 times 1 is 20. Here we get 10 times 0, right? Okay, if we're putting in 0, we get a 0 here. 10 times 0 times 1, that's going to be 0. So we're going to have 20 plus 0, so we get 20. So this is positive. So that tells me right now, second derivative is positive. So I know f of x is concave up on this interval. Okay, so let's check this one. Go back to my blue marker. And I'm going to put, it doesn't matter whatsoever. Just do f, the second derivative, plug negative 3 in there, put it into your calculator. You're going to get negative 0.5. It's actually 0.498, but you get the idea. So negative, 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 negative. So that tells me it's concave down right here. Okay, this problem only asked us for the intervals in which this function is concave up. So concave up is going to happen from negative 2 right here. See if I can actually get a color. from -2 to infinity. That is the interval in which this function is concave up. All right, sorry about the crazy writing in this one. Also, the derivatives are the worst part. The second derivative test will give you concavity. It's just like the first derivative test. Worst part of this problem for sure was that ridiculous function we started with and finding the first and second derivatives of it. All right, I hope this helped. Please put comments and questions and like and share. Do it all. And remember, I only solved this because a subscriber sent it in to me. So if you're not one of my subscribers, go ahead and hit subscribe. And then when you come to a problem this ridiculous, you can send it to me and I'll teach you how to do it. Thanks for watching.